Hello, everybody. Let me address here at the beginning of the semester something that you'll hear me do all the time, that I will use radius and diameter interchangeably when I'm comparing the size of two objects. So I might say, for example, that the sun is 109 times the diameter of Earth. Or I might say that the sun is 109 times the radius of Earth. Okay, and so I'm using both diameter and radius kind of interchangeably to say that the sun is 109 times bigger. So a lot of students ask this question and they say, and it's a good question, okay? We know that the diameter is twice the radius. So for example, here's a circle with the center and then the outside edge. The radius is the distance from the center to the outside edge. And so the diameter is twice that, the distance all the way across, so that the diameter is twice the radius. D equals 2r. Or for a sphere, okay, it's just, expanding that up into 3 dimensions. Here's a sphere. The radius is the distance from the center to the outside surface. And then the diameter is just the distance all the way across that, so it's twice the radius as well. Okay, now let's just look at some real numbers here. The radius of the Earth is 6,378 kilometers, and then the diameter of Earth is twice that, 12,756 kilometers. And then let's compare that, just to have something to use, with Jupiter. Okay, the radius of Jupiter is 69,911 kilometers, with its diameter twice that, 139,822. All right. Now, when we compare planets, we take the ratios of the radii, or the diameters, okay? So let's just do the radius. The radius of Jupiter is 69,911 kilometers, and then the radius of the Earth is 6,378 kilometers. So when you divide that, you get 10.96, or we'll just call that 11, okay? So that the radius of Jupiter is 11 times the radius of Earth, okay? Or I could say Jupiter is 11 times bigger than Earth by radius. Okay. Now, what about the diameter? What about the diameter of Jupiter compared to the diameter of Earth? Now, a lot of students are they're tempted to say, well, diameter is twice the radius, so if the radius is 11 times bigger, then the diameter would be 22 times bigger, right? Well, let's look into that. So, now it is true that the radius of Jupiter is 11 times the radius of Earth. We saw that. And it is true that the diameter of Jupiter is 22 times the radius of Earth. Okay? These are all true statements. It's also true to say that the diameter of Earth is twice the radius of Earth. So that's where the factor of 2 is in there. But when we do a ratio, we're going to see that those factors of 2 in the diameter divide out. So let's look. So what is the ratio of diameters? So the diameter of Jupiter is 22 times the radius of Earth. The diameter of Earth is twice the radius of Earth. So 22 times the radius of Earth divided by 2 times the radius of Earth is 11. The same proportion as the radii. Okay? When I divided and did a comparison of the two radiuses of Jupiter and Earth, I got 11. When I do the diameters, I get 11. Why is that? Because the diameter is twice the radius in both cases. That means that there's a 2 in the top of this fraction, and there's a 2 down here in the bottom, right? 2 times 11, that's where the 22 came from. And then 2 times 1 down here, that's where this 2 comes from. So the 2's in the top and bottom divide out, and you're just left with that same ratio of 11. So it holds true that the ratio of the diameters is the same as the ratio of the radii. So I can say that Jupiter is 11 times bigger than the Earth. So Jupiter is 11 times bigger than the Earth. It doesn't matter whether I'm saying radius or Jupiter. Or, pardon me, radius or diameter. Okay, I'll get it right here. I mean, you could script this all out and write it out and just write exactly or say exactly what you write, but it doesn't work that way. Let me make sure I'm 100% clear. It does not matter whether I use the radius or the diameters. They're going to both be the same ratio. Okay? So in this case, Jupiter is 11 times bigger than Earth, period. Doesn't matter whether I say radius or Earth. Okay, so I can use them interchangeably. You'll notice in my lectures or whatever, and even sometimes questions, I will say, oh, well, some planet is 10 times bigger than the radius of another, and then when I write a question about it, I'll say diameter, because it doesn't matter. Radius and diameter have the same ratio. Okay, hopefully that explains that. You can now believe it. Now you don't just know it, you understand it, and you can see why it's true. It has been proved to you. All right, have a great day. Talk to you later.